Mr. Elegante here, still on vacation. Different day, different shirt, shaved face. You might notice I've got my hard hat on because I've been spelunking at Yosemite. Behind me, you'll see one of the falls that's going on. It's been great fun here, but I didn't want you to miss out on your chemistry education, so I'm taking some time to record this podcast. Let's get to it. Solutions. We talked about solutions and colloids and suspensions and yada yada yada, but this is more about what makes a solution form in the first place. Okay, so let's look at it. Ions are things that have given up electrons or taken electrons. And in the last podcast, you actually saw sodium chloride being taken apart in water, and that is called dissociation. So ionic stuff pulls apart into its ions, but they're already ions. They're just pulled apart from each other. Molecular stuff, especially acids, that's the ones we're worried about. HCl, H2SO4, those are molecular compounds. Those are not ionic compounds. So when they get into water, the attractive forces between them are not strong enough to overcome the forces between the solvent and the atoms. So the hydrogens are ripped off of the hydrochloric acid, giving you hydrogen ions and chloride ions. In nitric acid, the hydrogens are ripped off of the nitrates, leaving you with hydrogen ions and nitrate ions. But if you had looked at HNO3 before it was put in water, you would notice that it is a molecular compound. They're actually sharing electrons. That's the difference between dissociation and ionization. Electrolytes are things that conduct electricity. So these are solutes that will allow for electrons to flow. Strong electrolytes let a lot of electricity flow. That greater than 95% means that greater than 95% of the molecules form ions. Either they were ionic before and they're breaking apart, or they're ripping themselves apart and ionizing. Strong things are things like hydrochloric acid, sodium chloride. Those are things that make lots and lots of ions. Weak things only ionize a little bit. So these are acids that you wouldn't mind putting in your mouth. Citric acid, acetic acid, or vinegar. Some of those things are things that ionize or dissociate very little. You could say the same thing for copper carbonate. Copper carbonate is insoluble. So that means that what little bit does dissolve, because a little bit will form ions, and it might let a little bit of electricity flow, but not very much. The easiest way to test for this is to hook up two leads to a power source and to a light bulb, stick them in the water, and see what happens. If the light bulb glows, then it's a strong electrolyte. If it only glows a little tiny bit, then it's a weak electrolyte. Not at all, then it's a non-electrolyte. So how do solutions happen in the first place? Well, solutions happen when water molecules, which are polar, they have positive ends and negative ends, as you can see here, interact with molecules like this. This is a sucrose molecule. Now, sucrose is made up of carbons, hydrogens, and oxygens. It's C12, H22, O11. And the interaction of those molecules allows for polar bonds to form, and there end up being negative ends and positive ends. Okay, so water molecules will orient themselves to that positive and negative end. What I want you to realize, though, is that pull of the water molecules is not going to be strong enough to rip the oxygen, hydrogen, and carbon away from each other. It's just going to be enough to take one sucrose molecule that you see right here and separate it from another sucrose molecule. So it's not ionizing, it's not dissociating, it's just surrounding the individual sugar molecules with water molecules. It doesn't split it up. Some molecules just stay molecules even though they're dissolved. So if we look here, and I run this short video clip, these are molecules of water coming up from the bottom, sucrose on the top. The water molecules surround the sucrose molecule, and what you'll notice is the blue ends, the positive end of the molecule, are oriented towards the negative end of the sucrose molecule, and the blue parts of the sucrose molecule are oriented towards the negative or red side of the water molecules. So it didn't rip it apart, it's just the water molecules surround it, And in a three-dimensional space, we call that a sphere of hydration. Okay? And it's that sphere of hydration that causes things to dissolve. If you can surround it with water molecules, it will dissolve. Now, if the molecule is too big, it won't ever dissolve because it's just way too large to stay surrounded by water molecules, and it'll end up falling out from between them. The water molecules just don't have enough pull to keep it separated from the other molecule. That's why some things which are insoluble, even though you mix them with water, just won't stay in the water. They fall to the bottom.